Hey kids, I hope you're using this, and if you're using this, you're going to owe me. You're going to owe me big because I spent a lot of time getting this ready for you. So I hope you do it. This should be downloadable on the website. I'll put it on the main page of my website. All right, and I'll say download for test review or something like that. Okay, so it should be there. You should be able to find it right on the main page. All right, so we're going to move. I'm going to answer a lot of questions about a lot of these things. So let's get moving. So this question says, what is the period? Well, if you remember, period is the time it takes to complete one full sine curve. All right, so in order to finish one full sine curve, you got to go up, come back down, go bottom, and back up. So there's one full sine curve. Well, you can't see it right now, but that says 4 pi. 4 pi. So my period is 4 pi. I'm going to show you another way to do that. Another way to do that is to figure out what B is. Now, if you remember, B equals frequency. And frequency stands for the number of complete sine curves in 2 pi. Well, how much of this sine curve do I finish in 2 pi? This is only half the curve in 2 pi. So period is also equal to 2 pi over b, in this case 2 pi over 1/2. Dividing by a half is the same as multiplying by 2, so if I multiply by 2 I get 4 pi. The next question is, what is the amplitude? So I chose to ask this question because so many of you are saying 1, 2, 3, 4. The amplitude is 4, Mr. Krause. No, it's not. The amplitude is 2. It starts here and moves up 2. Remember, you got to count on the y-axis. So in this case, the y-axis is 2. The last thing I'm going to ask you for is the equation. And I didn't put that on here, but the equation of this line is, let's see, the amplitude's 2. It's going up, so it's positive 2. Sine. B, we just figured out, B, the frequency was 1/2. That goes here. X. And there is no midline, so that's it. That's all she wrote. That deserves some more coffee because I need it. I'm tired. Let's do another one. By the way, if you're once again watching me perform like the performing monkey, great. You are going to fail tomorrow's test. If you can't do this stuff without me telling you how to do it, you're not going to pass tomorrow's test. So I would highly suggest before each problem you pause, try it on your own, and then come and see if you can do it. All right. Period. Time it takes to finish one full sine curve. Right there. It finished one full sine curve in pi over 2. So my period is pi over 2. What's my frequency? This one's tough. This one's tough. What is my frequency? My frequency is the number of complete sine curves. The number of complete sine curves in 2 pi. So let's see. 1. So I finished 2 that I got here. So I finished 2 sine curves in pi. So if I finish 2 sine curves in pi, that means I would finish 4 in 2 pi. So my frequency is 4. If I asked you for the equation, so I would say f of x equals, or y equals, my amplitude. Oh, got to get my amplitude. So in order to get my amplitude, I need my midline. There's my midline. So I know at the end of this thing, I'm going to be doing 1, right? So this is negative 1. So I'm going to be putting a minus 1 at the end. My amplitude is 1. It's going up 1. Now let me erase. If this is my midline, and this is my starting point, notice I'm going down first. So that would be negative 1, or just negative sine. And we said my frequency was 4. 4x. Now let's check period. Let's see if I got this period right. Remember, period is defined as 2 pi over b, which is pi over 2. There it is. All right. So this one says, what is the equation of this line? Well, the equation of this line is, the first thing I'm going to do is it's up 2. So I'm going to put a plus 2 on here. So I know it's f of x equals something plus 2 at the end. Figure out the amplitude. The amplitude is up 2, so positive 2. Now it's positive because notice I'm going up first. So 2 sine. Now the next question is, how many complete sine curves do I finish in 2 pi? Up, down, back. 1. Up, down, back. 2. Up, down, back. 3. I finished 3 sine curves in 2 pi. So this would be 3x, and that would be my equation. All right, children, let's keep going. All right, so what the question says is, what is the period for the following functions below? So period is defined as 2 pi over b. Okay, so period on this one is 2 pi over, this is b. Remember, this is a, this is my amplitude. So 2 pi over 2, which is just pi. What's the period of this one? It's 2, period is equal to 2 pi over, the number in front of the x, 4. Pi over 2. Now this next one is tricky. So before I do it, I'm going to drink. I really tried to trick you here. Notice I have a 5 that should be distributed. 5x minus 5 pi. So this equation is really 3/4 sine 5x minus 5 pi plus 4. So my period here is 2 pi over 5. So I probably tricked a bunch of you on there. So the first thing I do is get rid of those parentheses. That's kind of a tricky one. I would really make sure you knew that one. Max and min. Max and min, if you've forgotten, the formula for max and min is max is the midline, which is d, plus the amplitude, when the min is d minus the amplitude. Now remember, d is the number here. This is b, this is a, and this is c. Not all of them have c. This is d, this is d, and this is d. So in this one, I want max. I'll do 5 plus the amplitude. Now remember, the amplitude is 2. The negative just tells me we're going to go down first, not up first. So the amplitude is 2. So 5 plus 2 is 7. The minimum is equal to 5 minus 2, which is 3. Now you should be able to pause it right now while I take a drink and do the other two. All right, let's see how you did. Max. And if you're not pausing it, you're just watching me, you're silly. So max is d, which is negative 3. There's my midline, 3. Add 4, I get 1. And my min is negative 3 minus 4, which is negative 7. And finally, max is d, which is 10, plus max. Don't forget, we only care about the positive, not the negative. This is the amplitude. Plus 5, which is 15. And min is equal to 10 minus 5, which is 5. Ka-ching! Find the value of x, and I'm only going from 0 to 360. So when does, and I don't really care what this is. This could be 2x, this could be 3x, this could be 4x. But my question is, when does sine equal 1? Well, anytime it's 0 or 1, which all three of these are, we're going to draw the sine curve. Now, I don't care if it's negative 1 or positive 1, you draw the sine curve. And you got to remember what each piece represents. This here is 0. This at the peak is 90 degrees. This in the middle is 180 degrees. This is 270 degrees. And this is 360 degrees. So the question is, when does it equal 1? Well, there's only one answer to that. That one answer is 90 degrees. What if I ask the sine of 2x equals to 1? Well, what would x have to be? Well, I know this whole thing would have to be 90 degrees. Therefore, x would have to be equal to 45 degrees. What if I said the sine of 3x equals 1? Well, again, I know that the sine of this thing would have to be 90 is equal to 1. So in this case, 3x would equal 90 or x would equal 30. Not really sure why I did that. It doesn't really matter. Let me highlight these. Where does it equal 0? It equals 0 here. It equals 0 here. And it equals 0 here. But because I don't have equal to, my two answers for this one are 0 and 180 degrees. And then how many times does it equal -1? Well, it only equals -1 right here, and that would be at 270 degrees. That's it. Done with those. All right, so look at this. Sine, cosine, cosine, sine. You're going to see something like this. And you got to recognize that is this formula highlighted in green right here. Just happens to be highlighted in green. There's only 4 formulas you got to know, or 5. You got to know this one, 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 and you got to know this one. So whenever you see something complicated, take a look. Oh yeah, that's just the sine of A minus B formula, where this is A and this is B. Oh, well, that's really just sine then of 350 minus 20. Well, 350 minus 20 is really the sine of 330 degrees. And that's pretty easy to figure out, the sine of 330 degrees. So 330 degrees is down here. It has a reference angle of 30 degrees. So this is the same as the sine of 30 degrees. The sine of 30 degrees is 1/2. However, we are in the 4th quadrant and sine is negative. Let's take a look at the next problem. Just pause it. See if you can figure it out. Don't watch me. Pause it. Oh, plus. Let's look at our formula sheet. Oh, here it is right here. Plus A cosine, sine A cosine B plus cosine A sine B. That's that formula. So what this is really saying is, what is the sine of 130 plus 20? Oh, well, that's the sine of 150. 150 is in the 2nd quadrant. It has a reference angle, of 30 degrees again. I was kind of nice on this one. So this is the same as sine of 30 degrees, which is 1/2. And I say, okay, in the 2nd quadrant, sine is positive. So that's my answer. And finally, this last one, sine, cosine, cosine, sine. This time we're subtracting. So I'm going to say this is equal to the sine of 265 minus, this is A and this is B, 40. Well, that's really just equal to the sine of 225 degrees. Well, 225 degrees is going to be in the 3rd quadrant, and it makes 45. Anytime I ask you for exact, it's going to be angles that you should be able to work with. So whatever angle, even though you may not have known that this had a reference angle of 45 degrees, you should know it's going to be one of the ones that's nice. And it ends in 5, so it's going to be 45. So the sine of 45 degrees is the square root of 2 over 2, but we are in the 3rd quadrant, so it is negative. Find the exact value of, trying to look at my notes, sine of 2x if cosine x equals 3/5. So first things first, this is on your formula sheet. It's right here. I'll highlight it in whatever color I show up, green. So it right there. So it's 2 sine A cosine A. So we're going to rewrite this as 2 sine of x. Don't use A. We're using x in this problem. X times the cosine of x. Oh, okay. That's not bad. That's equal to 2 times something times something. Oh. Cosine's 3/5. That's cool. But you don't know this one. But you do know enough to find it. It says that angle x is acute, and acute means in the first quadrant less than 90 degrees. X. Cosine is 3/5. That's adjacent over hypotenuse. Now I can do the Pythagorean theorem, but by now you should be able to know that that's a 4. So what's sine? Oh, sine is 4/5. So I just take this whole thing and type it in my calculator. 2 times control division 4/5. Oh crap. Not even paying attention to what I'm doing. 2 times control division 4/, my goodness, 4/5 times 3 divided by 5. You'll see it fixes it. Oh no, that doesn't work. See how it messed up? See how it messed up? I think that's actually the right answer though. So had I put it in the right way, that would be the right answer. 24/25. Really what you do is multiply the numerators, multiply the denominators. All right, let's take a look. Sine of 2x again. So I'm going to do 2 sine x cosine x. So this is equal to 2 times something times something. Sine x is equal to negative 12/13. But I don't know cosine x. But I do know I'm in the third quadrant. So I come over here. I draw a triangle in the third quadrant. And I say, okay, sine is opposite 12 over adjacent, which is 13. I can do a little bit of math. And I can find out that this is 5 by doing the Pythagorean theorem. So cosine would be 5/13. But be careful of the sign. Is it positive or is it negative? Cosine is negative in this quadrant. Negative. So I got to multiply this stuff out. And if you multiply all this stuff out, you get 120/169. I added a problem here, so I'm going to add e to this in a second. So doesn't this look like what we were just working with? Doesn't this look like the sine of 2x formula, where this is my x value? So this is really equal to sine of 2 times 75. Because x is just 75. Well, what does that really mean? That really means that's the sine of 150. Okay. 150 is in the second quadrant. It has a reference angle of 30 degrees, so it's equal to 1/2. And since sine is positive in the second quadrant, this is positive. I'm giving you time. You should be hitting pause. Can you do this one? This one's the same formula. 2 sine cosine. That's the sine of 2x. Well, this is my x value. I gotta get a different pen. I gotta get back to my cool blue. This is my x value right here, 105. So this is equal to the sine of 2 times 105, which is really equal to the sine of 210. Well, 210 is in the third quadrant. It has a 30-degree reference angle. How did I get that? I took 210 and I subtracted 180. I just figured out how close it was to the nearest x-axis. All right. Well, the sine of 30 degrees, we've already done like 6 times, is 1/2. But in the third quadrant, it's negative. All right. One last one for you. I'm going to write it up, hit pause. So 2 sine 150 cosine 150. Hit pause and try this one on your own. So this is the same as the sine of 2x, where this is x. So this is equal to the sine of 2 times 150, which is 300. 300 is in the third quadrant. and it has a 60-degree reference angle because it's 60 degrees away from 360. So what's the sine of 60 degrees? Well, the sine of 60 is radical 3 over 2. But we're in the fourth quadrant, and in the fourth quadrant, sine is negative. All right, kids, moving right along. Anytime I ask for area, I just want you to use area equals 1/2 AB sine C. So in this case, 1/2 times 10 times 14 times the sine of 20. If I type all that in my calculator, half of 10 is 5. So 5 times 14 times the sine of 20. 23.9. 23.9, dot, 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 and then I just ask you to round that someplace. So again, pause it, see if you can do this one on your own, see if you can come up with it, round it to the tens place. Area equals 1/2, should have paused it already, 18 times 20 times the sine of 100. So half of 18 is 9, so 9 times 20 times the sine of 100. Enter. 177.26. Did you get that? Pause it. Did you get that? 177.26. Dot, 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 dot. Moving. So that's one way I can ask it. Or I can ask it this way. Find the measure of the angle or the side. Oh, I should have said this is of a triangle. Okay, so you have a triangle. I've given you the area, and I've given you the two sides. So obviously, I have to find the angle. So area equals 1/2 AB sine of C. So in this case, 50 is equal to 1/2 times Oh, I'm sorry, kids. I had to change this one. I have a note here. This one doesn't work, so I had to make this 18. So let's make this 18. Sorry about that. You have to make this 18. So 1/2 times 18 times 10 times the sine of C. Well, I'm going to just type all of this in my calculator. So I get 50 equals... So 1/2 times 18 times 10 is actually 90, is equal to the sine of C. Oops, times the sine of C. Divide by 90, and I get, I don't even know, sine of C is equal to 50 over 90, or 5 over 9. I don't really care. To find C, I do inverse sine of 50 divided by 90. Again, you could put 5 over 9. And I get 33.7 degrees. So C equals 33.7. If you got those decimals, great job. All right. Now we're missing the side. I should have put an X here. I apologize. I was moving quick. I've given you the area as 100. So 100 is equal to 1/2 times the side, 15, times the side I don't know, times the sine of 40. Well, what I'm going to do is I'm going to type this in, and this into my calculator and see what I get. So 1 divided by 2 times 15 times the sine of 40. And I get some really decimal, 4.82. So I get 100 equals 4.820 dot, 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 x. Well, to get x by itself, I just divide by 4.820, blah, 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 divide by that number. So I come over back to my calculator. I say, okay, calculator, 100, that's not 1,000, 100 divided by this equals 20.74. So x equals 20.7. So if you got that, great job. Moving on. Find the area of the shape below. All right, be careful with this one. I really think you might want to know this. Actually, you should know all of this stuff. This is really just two triangles. So if I use the area equals 1/2 AB sine C, but there's two triangles, I'd end up multiplying by 2 to get the answer. Well, 2 and the 1/2 just cancel with each other. So if I ever ask you the area of a parallelogram, you should use this formula. Just use the same formula, but without the 1/2. Or you can just double the answer when you get done with it. So 7 times 14 times the sine of 35. So 7 times 14 times the sine of 35, and I get 56.2. So hopefully you got area equals 56.2, blah, 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 blah. You guys do the next one. Pause it. Pause it. So again, I could use, I'll show you how another way to do it. I could say, okay, only thing I know is the area form of a triangle. So that's 1/2 times 15 times 10 times the sine of 120. So I could find that. 0.5 times 15 times 10 times the sine of 120. And I get this. But that's only this part of it. To get this part of it, I got to double it. So I just multiply by 2 times 2. And I get 129.903 something. Or I could go back up here and I could say, look, just get rid of the half. We don't need this half. Just do this. Do it without the half. And you get the same answer right away. Good. Write the equation for the sine curve with the given information. Ooh, this one's tough. So I know it's got to be y equals a sine bx plus c. Okay, let me get my other pen. So, I have amplitude. And it didn't say positive or negative, so let's just assume it's positive. So 3 sine x. And I'm moving down 2, so that's minus 2. So the only thing I really got to figure out is this. Well, it's not pi over 4. So wait a second. Period is equal to pi. Wait, what's the formula? Pi over 4, right? But isn't the formula 2 pi over b? Isn't that the formula for period? So if period is equal to pi over 4, and I know the formula is 2 pi over b, I can use this formula to find b. Cross multiply. Pi times b is equal to 8 pi. Divide by pi, and I get 8. b is equal to 8. And there's your answer. Now, if you don't believe me, let's check it. Isn't period equal to 2 pi over b? So period is equal to 2 pi over b, which is 8. Well, 2 over 8, isn't that really just 1 over 4? Pause it for the next one. Try it on your own. Great, you're back. Let's try it again. Let me do a different color. Let me go back to purple. So I'll use f of x this time because it's really cool. So I know my amplitude, 2. Sine, I don't know the frequency, and I'm going up 5 units. So I'm going to add 5. Frequency is a little trickier though, but I know that the period is equal to pi over 1, which is equal to 2 pi over b. Cross multiply, or you can just realize that b's got to be 2 in order for this to be pi, but I can do pi times b is equal to 2 pi. Divide by pi, and I get b equals 2. So there's my equation. So finding b is the hard part, but you got to use this formula. All right, moving down. Oh, so we're going to get into some tricky stuff. So I got 2 of these and then 2 more. I got 4 more questions. I think I got 4 more questions for you. Yep. So let's think about these. Remember what the first thing is I told you to do. Find all of the angles. All right, so we're going to find all the angles. I should have probably drawn that a little bit better. So this is 55, and this is 90, And those add up to 145, so this should be 35. And here's our hunter. And he's trying to catch the wabbit. These have to add up to 180, so this has to be 145, right? Because these two have to add up to 180. Now, let's see. If this is 55 and this whole thing is 70, this piece has to be 15. And if this is 145 and that's 15, those add up to 160, this has to be 20. Now, my ultimate goal is to find this value here. But I can't touch this triangle until I find the side that they share. So I want to find the side that they share. So let's see. Oh, the cliff height is 300. So I'm going to put y over 90, y over the sine of 90 is equal to, the only thing I know is this is 300 over the sine of 35. Cross multiply, I get y times the sine of 35 is equal to 300 times the sine of, well, sine of 90 is just 1, right? So it's really just 300. But I can put that in my calculator just to show you that this makes no difference. Control division. Oh, I haven't finished. I'm going to divide by the sine of 35. So I come over to my calculator. I'm going to put in 300 times the sine of 90 all over the sine of 35. So 523 and that stuff. So I know that y is equal to 523. Now you're going to show me all your in-between work. 034, 038, 034, 038. So now I know y. Now I can get into this triangle over here. I'm going to put y over this thing. So let me get a different color. So 523.034038 over the sine of 20 is equal to, now I want to find x over the sine of 15. Cross multiply, I get x times the sine of 20 is equal to 523.034038 times the sine of 15, cross multiplied. Get rid of this 20, sine 20, divide by sine 20. And I get x equals something. So 523, control division. Now, I'm not retyping that. Enter. Times sine 15. All over sine 20. Equals 395. And if we round it to the nearest foot, 396. So x equals 396. Now, okay, I did that one. Now you do this one. This one's slightly different. How far has the plane traveled? So I'm looking for x. So at this point, you should probably be pausing it and seeing if you can figure it out. Now, if you can't pause it, if you haven't paused it and you're still waiting for me to figure out some things. By the way, this is my plane. Just not very good. So anyway, if you're looking for a little help, maybe this helps. And I believe the first thing I told you guys to do was to find all of the angles. That's the first thing I'm going to do. I'm going to go find all of these angles. Let's see. That's 50. And that's 70. That makes this 20. Now this is 90. Now this is also 90 down here. And if this is 70, this has to be 20 as well. Let's see, 50 plus 20 plus 20, that's 90. Good. So this is 90, and that's 20. This has to be 70, because 20 plus 70 is 90, plus 90 is 180. If this is 70, this is 110. If this is 20, and that's 110, that's 130, that makes this 50. All right, found all the angles. Great. The other thing it said was the plane is 2,800 feet in the air. So this is the plane's height, 2,800. But that's kind of useless way over here. So let's put it way over here. Same line, just don't need it over here. All right. So I want x, but x is in this triangle over here. So I got to go through the middle. So we're going to try y. So y over the sine of 90 is equal to 2,800 over the sine of 70. Well, this is just 1. So really it is, what I have here is y equals. But if you don't like that, you can cross multiply. 2,800 times the sine of 90 is equal to y times the sine of 70. Divide by the sine of 70. So really what I end up here is 2,800 over the sine of 70, but whatever. So control division, 2,800, escape. 2,800 over the sine of 70. 2,979, so y equals 2,979.6977, 697 something like that. So now I know y. Cha-ching! Now I want to find x. Well, y is opposite the 50-degree angle. So I'm going to do y over, oh wait, I know what y is. Y is 2,979.6977629 over the sine of 50 is equal to x, which is right here, and it's opposite that little angle right there, which is 20. So x over the sine of 20. Cross multiply. X times the sine of 50 is equal to 2,979.6977629 times the sine of 20. All I did was cross multiply. Divide by sine 50, and I'm finished. So this number, control division, this number times the sine of 20, all over the sine of, I think it was 50, wasn't it? And I get 1330.36. Yep. X equals 1330. Should have divided this side by sine 52, right? 1330.36. So x equals 1330. All right, kids. Final steps. By the way, this has to be a 14. Otherwise, it doesn't work. All right. So let's see what we got here. It's a cubic. So the first thing I'm going to do is change my purple pen because it should be cool. I'm going to take out sine of theta. So it leaves me 16 sine squared x minus 14 sine x plus 3. Now I'm going to factor this. Sine of theta now I could factor it or I could cheat. Menu 3, 3, 1. Enter. My numbers are 16, negative 14. And positive 3, right? Oh, I think that's what they were. Click OK. Click Enter. Click Enter. So I get 3/8 and a half. So my answers are sine theta equals 3/8. Sine theta equals 1/2. Well, now, to put them back in here, well, these have to both be negative then, because these are both positive. They have to be negative. The 3 comes here. The 1 comes here. But don't forget this 2 really comes out front. So 2 sine theta. And this 8 really came from out front. 8 sine theta. All right. And then don't forget you have this thing over here. I don't know where a pen went. You also have sine theta equals 0. All right. So this one we're going to draw a picture. And I get 3 answers. 1, 2, 3. And we've already discussed those. Those are 0, 90, and excuse me. 0. This is 180 and 360. Now these two are going to be a little bit more difficult. So I have to inverse sine. Inverse sine 3 divided by 8. And you get, well, let's just round to the nearest degree, 22 degrees. So theta is equal to 22 degrees. And this one I know theta is equal to 30 degrees. Okay. Now, both of these are positive. So that means for both of them, we're going to be in the first and the second quadrant. So let's deal with the 22 degrees. 22 degrees. Okay, that's one of our answers. Okay. For this one, we have to do 180 minus 22 degrees, and that would be 158. This one is 30, and hopefully now you know this is 150. So my 7 answers are 0, 180, 360, 22, 158, 30, and 150. Wow, 7 answers. Let me see. Did it say? And it did say equal to 360, so I have to include 360. All right, kids, last problem. Once again, I got a GCF, so let me take that out. That's the sine of x. So I get 20 sine squared x plus 11 sine x minus 4 equals 0. So sine of x. Now, I could say, okay, now I know I'm going to have sine of x equals 0, sine of x equals something, and sine of x equals something. So I can factor this, can man up and just factor it, or I can cheat. 20, 11, negative 4. So menu 3, 3, 1, 20, 11, negative 4. Hit enter, enter, enter. Negative 4/5 and 1/4. Negative 4/5 and positive 1/4. So now let me show you, remind you, you got to put these back. So this is negative, it's going to go back as a positive. This is positive, it's going to go back as a negative. This 1 comes here, and the 4 goes here, and the 5, remember, slides out front. So 5 sine theta. And the 4 goes out front, so 4 sine theta. All right. Now I got my hard work to do. Now, that's the easy part, believe it or not. That's pretty tricky. So I hope you know how to do this. So this one, I draw a picture. Once again, 0, 180, 360. This one, I'm going to do inverse sine on. So inverse sine. Notice I am not putting the negative in. It's just inverse sine of 4/5. And I get 53 degrees. And then I'm going to do inverse sine of 1/4. (14.4), so this is 14 degrees. All right, now I have to decide if I'm going to keep them. On this one, we have negatives. Well, sine is negative in the 3rd and the 4th quadrant. So I'm not going to keep this one, but I do need to use it. So for this quadrant, I'm going to do 180 plus 53. And I get 233. And for this one, I'm going to do 360 minus 53 degrees, and I get 307. This is positive, and sine is positive in the first quadrant and the second quadrant. So I am going to keep the 14 degrees. But for the second quadrant, it's 180 minus 14 degrees, which is 166. So once again, I have 7 answers. 0, 180, 360. That came from these 3. 233, 307. That came from these 2. And 14 and 166. All right, kids, that's it. Study. Now, I didn't cover everything. There's things like how many triangles. That's definitely going to be on there. How many triangles? Can I keep 1 triangle, 2 triangles? You got to be able to know that too. All right? So that's it, kids. It's been fun and it's been real, but not real fun. Bye.